Since I have a meeting this afternoon, I'm going to go ahead and record the notes for Mars. You can go to the regular PowerPoint if we didn't get through all of the Earth notes in your particular class. So when we look at Mars, then once again, going through and understanding, my very educated mother tells us that it goes Mercury, Venus, Earth, and then Mars. So it is the fourth planet in our solar system going out from the sun. It should make sense that its AU, its distance from the sun, is going to be greater than ours because it's the fourth planet from the sun and Earth is the third planet from the sun. Once again, 1 AU is the average distance of Earth from the outside edge of the sun. So when we look at the AU for Mars, we're now going 1.5 times further out than Earth is at 1.52. Looking at its year, then, we have hopefully, once again, the understanding that the further out I go, the longer the years are going to be. Because once again, a year is a revolution, and scientifically that means how long does it take for it to go around the sun? When I look at Mars, it's going to take 687 Earth days to go around the sun. Now let's think about what that means, because in our time on Earth, it goes around the sun in 365 days. So what we're saying is that 1 year on Mars is equal to about 1.9 Earth years, almost 2, right? So if I wanted to know what my age is on 9, quickly I could divide it by 2. If I wanted to know the actual, then I would divide my age by 1.9. So let's say you're currently 12. If you divided that by 1.9, then what we're saying on Mars, you are 6.3 years old. When we look at its period of rotation, then this is where it's very similar to Earth. So it's 1.03 Earth days. What that tells us when we translate that is it spins on its axis in about the same amount of time, a little bit longer, but about the same amount of time as Earth spins on its axis. So in 1 day and 37 minutes, or 24 hours and 37 minutes, then Mars is able to rotate, spin one time all the way around on its axis. Other than its day, another thing that it has in common with Earth is it has an atmosphere. Right? Now, our atmosphere, once again, has 5 different layers, starting at the troposphere, going all the way out to the exosphere where we find the moon. This only has about 2 layers, and the majority of the gases are carbon dioxide that we're going to find on Mars. The problem with us trying to get to Mars is that we can't breathe carbon dioxide. It's toxic to us and it would end up killing us. So if man's going to go to Mars and land there, we have to either take all of our oxygen with us or figure out a way that we can create oxygen. So when I look at temperatures then, this is where we've got a little bit of a similarity to Earth, but then a big difference. And we're going to start with the big difference. On the far side of Mars, even though it does have multiple moons, it doesn't trap the sun's heat like our planet does. So the far side of Mars is negative 140 degrees Celsius. Once again, that's not the American way of measuring temperature. So when we look at that in Fahrenheit, then what we're seeing is negative 220 degrees Fahrenheit. So about 12 hours, 15 minutes of each day on Mars, you're in extremely freezing cold temperatures. The middle of the day at the equator on Mars, though, is actually a pretty comfortable temperature. It's 20 degrees Celsius, but what that translates to us is 68 degrees Fahrenheit. That's pretty close to the average temperature of Florida during the winter season. So we would be wearing, t-shirts, maybe jeans. Some of us would be wearing shorts. That's pretty comfortable for us. But once again, that's at noon and at the equator. So since it's a 24-hour period basically in the day, that we don't have a lot of time at really comfortable temperatures. If we're going to send people to Mars, we have to figure out a way where they can sustain the extreme cold of negative 220 degrees Fahrenheit. Once again, when I look at the idea that it has an atmosphere, kind of like Earth, when it has a day where it has different temperatures, then it should make sense that we also have weather. Now, the original noticing of weather, other than we could see that the soil had been shifted, is we were able to take with a satellite a picture of a dust devil. So if you don't know what a dust devil is, it's just basically a small tornado that is picking up sand. So if you think about small tornadoes out in the deserts of Arizona, they're called dust devils. And we noticed that we could see these popping up every once in a while on Mars. Well, we also know that Mars is red. So trying to figure out what materials the dust devils are picking up, then we had to start studying the surface of Mars. Now, the ancients looked at Mars, saw it was red, and figured that there must be people that lived there that were constantly in battle because the ground was covered in blood. Well, that's not the case. But we know they weren't always the most logical. But because they thought it was covered with blood, they chose the Roman god of war, which is Mars, to name the planet after. And anytime I see Mars in original paintings and things like that, he's usually in his military garb, but he has a sword or a spear or a shield or all of it, and it's usually covered with blood. And in this picture, you should be able to see that on that shield, there's a lot of blood on it. So they figured that they would name Mars after him. His counterpart in Greek is Ares, in case you're wondering. Right? But when I look at it, I need to know what it is. It's not blood, right? It's definitely not just dirt. So when I started able to send space probes out and look at the actual soil and do some examining, we had some rovers that landed on Mars and are still currently there taking images and sending us information. But we discovered that the entire surface is indeed red, and then there are some just regular kind of grayish, dark colored rocks. A really close up picture of the soil is on the right from one of our rovers. When they tested it, they found out that that is iron oxide. Now, we have iron oxide in a lot of places on our planet. We simply call that rust. So if you think about what causes things to rust, and I have tools that have rust on it because my youngest son has a tendency to every once in a while leave my tools out in the rain and they get rusted. So we need two different things. We need metal and we need liquid in order to cause rust. So when we look at the idea of there being water, there's a little bit of water, yes, not much. And generally during the day, it's going to evaporate and then it freezes at night. But the majority of the water is located inside of the first layer or the first inch of soil. And that's why the majority of that is going to be rust because there's also particles of metal throughout the soil of Mars. And when we talk about water, this is an image of one of the craters, and there are a few craters on Mars, not nearly as many as Mercury. But when we go from night into the morning time, then right in the center, you can see a pool of water. And we did send a land rover down there to do some studying and test it. And what they found out is that the water does have a tendency to collect there and then freeze overnight because it gets so cold. And then it's going to warm up as day is coming along in the morning, and it either gets absorbed into the soil again or it's going to evaporate. But when we think of water, we think of just clean H2O that we can drink or maybe the ocean. But this is what is considered acidic brine water. What that means is that the salt content, all of the metals and minerals that are on the surface of Mars, cause it to be extremely salty, like an acid, right? So acidic brine water is not water that could be consumed by any human being. So if we do send people to Mars, then we've got a water issue. So maybe we notice then that Mars has polar ice caps, a northern polar ice cap and a southern polar ice cap. And we might think there must be some water there. Well, there is, but once again, when we send rovers there to test it, it appears that it is frozen acidic brine water. So it's that acid water completely frozen, but most of it isn't even water at all. Most of it is dry ice. And if you didn't know, dry ice is when we take carbon dioxide and we freeze it, right? So if you do a lot of exhaling into a container and then we freeze it, you end up with what is called dry ice. It's why when I take dry ice and I sit it out and it begins to heat up, it turns into a fog because it evaporates quickly into the gaseous form. So we really can't use that either in order to sustain life. Now, this, what I often refer to as the pimple of Mars, because to me it looks like a giant pimple on Mars's forehead. That is Olympus Mons. Right? So Olympus Mons translates to be the mountains of the Olympians. This is the largest known mountain in all of our solar system, and we've studied several of like the planets, uh, inner planets, but also the moons of several of our extraterrestrial planets. But this is still the largest mountain that we know of. It is believed to be an extinct volcano and therefore the dip right in the very center. And there have been traces of a type of lava that has been detected from our rovers. But when I say the largest, we need to understand that on our planet, we have two very large mountains. One is Mount Everest that most people realize, but we do have an volcano that is not currently erupting called Mauna Kea. And the last time it erupted, it actually got a little higher than Mount Everest. Those would be what our two largest mountains on Earth look like. If I would put Olympus Mons in that image, that would be the comparison. It is far bigger than either of our largest mountains on our planet. If I look at the United States of America just to get an idea, I look at the state of Missouri, it's going to cover almost the entire state of Missouri. It is that large of an extinct volcano, right? If I look at the globe from space and I look at where Hawaii is, I can barely see it because it's pretty small in comparison. The other land feature that we have on Mars that is quite popular is this kind of like a gash type thing. Scientists do hypothesize that something had come along at one time or another billions of years ago and scraped the edge of Mars. I don't really know. I wasn't around back then, so I can't tell you what caused it. But what I can tell you is its name is the Mariner Valley. And when I look at it, it's also the largest canyon now that we know of in our entire solar system, right? And a canyon is a deep carving through rock, right? So the outer layer, right? When we look at its size, then in comparison, it's about the same distance as the entire length of the United States, right? That's a good 3 days drive from the East Coast to the West Coast, or vice versa. So that's a pretty long distance all the way across. If I want to get an idea of what that would look like, if you've ever been to the Grand Canyon, right? It's pretty small. That would be it in comparison to the yellow line, which is the Mariner Valley. And I can't see it from space. I can definitely see the Mariner Valley from space. The other thing we look at that's interesting about Mars is it has two moons. So we went from 0 on Mercury, 0 on Venus, 1 on Earth, which is pretty large. And then we get the two moons of Mars, and they're some of the weirdest looking moons that we have in our solar system. Their names are Deimos and Phobos, and often referred to as the potato moons, because people say they look like potatoes. They got their names because once we discovered that they were there, then we looked at mythology. If we looked at Greek and we look at Ares, then he had two horses that pulled his carriage. But when we look in the Roman mythology, we look at the sons of Mars and same names. We have Phobos and Deimos. And those names translate into fear and panic. So just an interesting factoid for you. If I think about Hercules, the movie that Disney created, that is fear and panic. So Hades' little minions are named after the sons of Mars, which are also the moons of the planet Mars. We have sent more than 20 missions to Mars. So when we look at our space probes, the ones that have meant the most to us are the ones that landed. So in January of 2004, just a few days after my youngest daughter was born, we had two different rovers land in different spots on Mars. And they started sending images and studying the soil and looking at rocks and going into the craters. We had the Phoenix mission that landed in May of 2008 to do some drilling to see if we could find some water in different locations. And then in July of 2020, just 1.5 years ago, we sent out the Perseverance. It launched and it actually landed just a year ago. So on February 18th of 2021, it landed and it sends us images. Now, the original Land Rover, Spirit and Opportunity, were predicted to only last for about 3 years because we knew that there were storms and things like that on Mars, and therefore we figured they would get covered up with the dust and no longer work with their solar panels. But what we found out is the storms actually blow off all of the dust and debris, so they've continued to work. Right? All of our rovers that we have sent there, even all the way back from 2004, they're continuing to collect data and send us images and information. So what NASA has decided is that in 2026, just 4 years from now, they are going to attempt to send a crew of men, and I say men as in human beings, right? There'll be women there also, right? To go to Mars for the very first time, having someone walk on something out in space other than our moon. So it's interesting times we live in as technology continues to increase. All right, so that's all the information I have for you on Mars. Please make sure you have your notes written down. This won't take up your entire class to take your notes, but you may then get your assignment from the person who's watching my class during my meeting, and it is due first thing tomorrow.